Hello students, welcome to Yonoya. My name is Rizwan. I hope you all are doing well. So in this video, we will be discussing about the difference or the differences between roots and zeros. Okay, these two are the terms that we are using in mathematics frequently. Okay, they are not equal. Okay, we have some differences between them. Okay, we can see sometimes people are using them in wrong places. Okay, that means in some cases we can see using of roots instead of zeros, or using of zero instead of roots. Okay, so these mistakes are happening many times with lot of people. Okay, so we should know the difference between them to avoid these mistakes. Okay, so let's start our discussion. Yeah, so here we will be discussing about the difference between roots and zeros. Okay, roots and zeros. Yeah, so let's discuss the difference between roots and zeros. Here you can see roots, and here we will discuss about zeros. Okay, so roots and zeros. Okay, so the first difference is roots are for equations and zeros are for polynomials. That is the first difference. Okay, you should understand this difference first. Okay, then only you can avoid making mistakes. Okay, so roots, you can see, they are for equations. Okay, equations, and zeros are for polynomials, not for equations. This is the first and major difference. Okay, and what is mean by equation and what is mean by polynomials, or what are the difference between them? Okay, equation, in equation you can see an equal to symbol, right? And you will find something on the left side of that equation, left hand side LHS, and on the right side of that equation, right hand side RHS. But in polynomials you cannot find an equal to symbol. Okay, you will just find an expression. Okay, so this is the difference between an equation and polynomial. Okay, so here I will write the general form of an equation. You can see ax square plus bx plus c equal to 0. This is an example for an equation. But what about for polynomials? In the polynomials, you cannot find this equal to symbol. This symbol, you cannot find it in polynomial. You will find just an expression. You can take the same expression, ax square plus bx plus c, and that's all. You should stop here. Okay, no equal to symbol. Okay, you can add more terms, but you cannot find equal to symbol there. Okay, so this is an equation and this is a polynomial. Okay, in equation you will find this equal to symbol. On the left side you will find something, this is known as LHS, left hand side, and on right side you will find some other things. Okay, this is known as right hand side RHS. But in polynomials you cannot find such things. No equal to symbol, no equality symbol, and you cannot find there is no left hand side and right hand side, no LHS and RHS. Okay, so these are equations and these are polynomials. Okay, so roots are the terms that we are using for equations only, and for polynomials we will use zeros. Okay, so roots for equations and zeros for polynomials. That is a major difference. Okay, then next we can say that roots are those values of the variable in an equation which satisfies the equation. Okay, for example, let's take this equation ax square plus bx plus c equal to 0. This is an equation and x is the variable. Okay, here x is the variable. Here actually a, b, and c are numbers. Okay, you can find any real numbers there. Okay, generally we can write a, b, and c. I will write an example for you. X square minus 7x plus 12 equal to 0. This is an example. Okay, here in the place of a you can see 1. This is x square simply means 1x square. Okay, in the place of b you can see minus 7. That is coefficient of x, and the c is the last constant, the last number, that is 12 here. Okay, so this is one example. So x is the variable and you can see coefficients with that. So roots means those values of x Which values of x? The values of x which satisfies this equation or any equation. Okay, so that values of variable or x, okay, are known as roots of that equation. Okay, so these are roots. Okay, so you cannot find the equation satisfying in any value of x. Okay, okay, you can if you put x equal to 1, you will get you will not find this equation is correct. Okay, so you have to that means we have only very few values. Okay, only for a few values this equation will be correct. For other values the equation will be wrong. Okay, the equation will be wrong. Okay, so only those values at which this equation is correct is known as roots. Okay, is known as roots of the equation. Okay, now what about zeros of the polynomials? Zeros of the polynomial means those values of variable. Here it's x. So those values of x which makes that polynomial zero. That means if you substitute that number in the place of x, okay, which number? Zero. Okay, not a zero number exactly, but it's a term. Okay, not exactly zero number. Okay, it's a term. That means zero means that number. What is the peculiarity of that number? If you put that number in the place of x in the polynomial, that entire polynomial becomes zero. Okay, it becomes zero. It vanishes. Okay, so in the case of polynomial, also I'm taking the same example: x square minus 7x plus 12. Okay, no need of this equal to symbol. Only this much. Okay, this is enough. Okay, or this is the polynomial. Or if you want, you can put 1x square. Okay, so this is the polynomial. Okay, what is zero? Zero means here x is the variable. Okay, x is the variable. Okay, you can put many values for x. You can put any real number for x. Not like this. Here you cannot put any real number for x. You will find only few numbers. Okay, you will find only few numbers for x. If you put only that number, then only the equation is correct. That numbers are known as roots. But when it comes to here, the polynomial side, actually you can put any real number for x. No problem. But if you put only few real numbers, only few numbers, then only this polynomial becomes zero. Okay, that values are known as zeros of the polynomial. Okay, here you will, if you put 1 for x, you will get one value for the polynomial. If you put 2 for x, you will get another value for the polynomial. Okay, no problem in putting those values. But if you want to become if you want this polynomial to become zero, you have to put only some values. Okay, only some selected values. Okay, only few values. That values are known as zeros of the polynomial. Okay, zero of this polynomial. Okay, I will explain both. Yeah, so let's come to this equation. First, I am going to put 1 in the place of x. Okay, x equal to 1. I'm trying with 1. Okay, so 1x square becomes 1 into 1 square because x is 1. Okay, wherever you see x, put 1 or substitute 1. Okay, minus 7x becomes 7 into 1. Okay, plus 12 equal to 0. Then 1 into 1 square becomes 1 only. So 1 minus 7 into 1 is 7. So 7 plus 12 equal to 0. 1 minus 7 is minus 6. Okay, minus 6 plus 12 is 6. So 6 equal to 0. This is wrong. 6 is 6, 0 is 0. They are not equal. Okay, so but we have reached in this situation 6 equal to 0. This is actually wrong. So we can say that x equal to 1 is not a root, because after putting x equal to 1, you are not getting this equation satisfied. You are getting in a wrong place. You are reaching in the wrong place. Okay, so x equal to 1 is not a solution. Okay, sorry, yeah, solution or root. X equal to 1 is not a root of this equation. Now let's put 3 in the place of x. Okay, let's put 3. Let me remove this. Yeah, now I'm going to put 3 in the place of x. Okay, x equal to 3. So what will happen? 1x square becomes 1 into x square, that is 1 into 3 square. 3 in the place of x. Substitute 3 in the place of x, all x. Okay, minus 7x becomes 7 into 3 plus 12 equal to 0. Let's see whether it's correct or not. 1 into 3 square is 9. Okay, 3 square is 9. 1 into 9, 9. So 9 minus 7 into 3, 21 plus 12 equal to 0. 9 minus 21 is minus 12. So minus 12 plus 12 equal to 0. Minus 12 plus 12 is 0 only. So 0 equal to 0. 0 equal to 0, it's correct. Okay, so this equation became correct, or this is satisfying this equation. That means x equal to 3 is a root of this equation. Okay, is a root of this equation. Correct. So we can say that x equal to 3 is a root. In the same way, you can see x equal to 4 also. If you put x equal to 4 also, you will see this equation satisfied. You can try. Okay, so these are the roots of equations. Now, when it comes to zeros of polynomial, I told you that here you can put any value for x, any real number you can put. But here it's not possible. Only in the case of x equal to 3 and x equal to 4, this equation is correct. For other numbers, this equation is not correct. So these two are the two possible values. These two are the roots of this equation. But when it comes to 0, you can put any value for x actually. Sorry, when it comes to polynomial. Okay, when it comes to polynomial, you can put any value for x. For example, let's put 1, x equal to 1. If you put x equal to 1, you will get a corresponding value of this polynomial. So 1x square becomes 1 into 1 square, minus 7x becomes 7 into 1 plus 12. 1 into 1 square is 1. So 1 minus 7 into 1 is 7 plus 12. Okay, 1 minus 7 is minus 6. So minus 6 plus 12, that is equal to, that is equal to 6. Okay, it's okay, fine. That means we are putting 1 for x. This polynomial is becoming 6. Okay. So the value of this polynomial at x equal to 1 is 6. That is okay. Now let's put x equal to 2. Let's put x equal to 2. X equal to 2. That is also possible, you can put. So 1x square becomes 1 into 2 square, 2 in the place of x. Okay. Minus 7x becomes 7 into 2 plus 12. Okay. That means 1 into 2 square. 2 square is 4. So 4 minus 7 into 2 is 14 plus 12. Okay. That means 4 minus 14 is minus 10. Okay. Minus 10 plus 12. Okay. That is minus 10 plus 12 is 2. That means if you put x equal to 2, this polynomial becomes 2. It's okay. But here 1 and 2, we try two values, 1 and 2. Okay. But in the case of both of these values, we are not getting this polynomial reducing to 0, right? In the case of 1, it is getting 6. Polynomial is becoming 6. The value of polynomial is 6. But in the case of 2, the value of polynomial is 2. In both of the cases, the value of the polynomial is not 0. At what value we will get the polynomial 0? That values are known as zeros of the polynomial. Let's try 3. X equal to 3. If you put x equal to 3, this polynomial becomes 1 into 3 square minus 7 into 3 plus 12. Okay. That means 3 square is 9. 9 minus 7 into 3. Sorry, it's not 13, it's 3. Okay. 7 into 3 is minus 21 plus 12. Okay. 9 minus 21 is minus 12. Minus 12 plus 12, that is equal to 0. That means if you are putting x equal to 3, this value of the polynomial becomes 0. That means 3 is a 0 of this polynomial. Okay. In the same way, you can see with x equal to 4 also. Please try this. Okay. So here we can say that 3 and 4 are zeros of this polynomial. That doesn't mean that we have to put only these 3 and 4. No. You can put any value for x. You will get the corresponding value. For example, if you put x equal to 1, you will get 6. If you put x equal to 2, you will get 2. Similarly, if you get x equal to 5, you will get another value. So all those are values of the polynomial for different x value. But if you want 0, you have to put only 3 and 4. Those values, this 3 and 4, are known as zeros of the polynomial. Okay. But when it comes to roots, you cannot put any value for variable. Okay. You cannot put any value. Only some values are possible. For example, in this case, in this equation, there are only two possible values, x equal to 3 and x equal to 4. You can put only these two values for x, or x can take only these two values. For other values, you cannot satisfy this equation. You will satisfy this equation only if you put x equal to 3 and x equal to 4. 3 for x and 4 for x with these values. Okay. So these two values, 3 and 4, are known as roots of the equation. Okay. So this is the major difference between roots and zeros. Okay. You should know the difference to avoid mistakes. Okay. Yeah. So roots for equations and zeros for polynomial. Okay. You should begin with this difference. Okay. Okay, students. So I hope my explanation is clear for you, and I hope you enjoyed this video. Okay, so please practice more questions. Okay, more questions with this. Okay, so thanks for watching. See you next time. Take care. Bye bye.